Hello, welcome back to algebra. Today we're going to continue studying statistics, and our topic today is going to be scatter plots and correlation. So scatter plots, I like to help you remember what that looks like by thinking scattered dots. You're not going to have a straight line, you're not going to have bars, you're not going to have a box, you're going to have scattered dots. And so this is a way to compare two different data points. So in example 1, we had a study and they are asking people how many hours they sleep, and then they're giving them a cognitive test, a thinking test. And so they're wondering if sleep affects how well you can think. And so they've written down the sleep score and the cognitive test score, and now we're going to graph those and see if there's any connection between the two. The connection is called a correlation. All right, so the first one's 3 hours and they got a 50 on the cognitive score. The next one, they slept 7 hours and their score was 70. 5 hours was 60. Another person said 5 hours, but they had 70 on their test. 8 hours was 70. 6 hours was 60. Another person said 8 hours and their score was 80. Someone said 9 and their score was 80. One person said they slept 10 hours and their score was 90. All right, so that is our scatter plot. And you can see it does look like scattered dots. And what we're going to do is we're going to identify a line that goes through this path of points kind of in the middle. We call that a line of best fit. Now, a line of best fit won't always be a line. It might be a curve, it might be quadratic, or it could be exponential, but we're going to start off with a line. This one, well, you can kind of see that there is a line of a path of dots that's going in, kind of a line, loosely gathered near this line. And so what you want to do is you want to try to find a place to draw the line that goes kind of through the center. So that line is pretty good. It goes through mostly the center. But notice that I have 4 dots below and only 1 dot above. So I think it would be good to redraw this at a slightly different slope so that it's more centered. All right, so this one now is a little more centered. Let me erase the old line so it doesn't confuse you. Because look, we have 2 dots below and 3 dots above and about 4 dots on the line. So that's why this one's a better line of best fit. So our line of best fit here is simply the centered path through the points. Now, since it's a line, we're going to write the equation. So the y-intercept appears to be somewhere above 30, and we can get that more precisely by using 2 of the points that are on the line. So this one is at 350, and it's good to spread out. Don't do 2 that are really close together. This one's at 980. So this is either end of the line. So we can find the slope first. 50 to 80 went up 30. 3 to 9 went up 6. And so the slope is 5. Now we can identify the y-intercept by putting in one of these points for x and y. So I'm going to say y is 50. And then our slope is 5 times x, which is 3. By the way, this, just as a reminder, this is y equals mx plus b that I'm using. This is 15, so if I subtract 15 from both sides, my y-intercept is actually at 35. So mine is not as accurate as it should be. That's why it's good to use 2 points instead. So the equation of this line of best fit is y equals 5x plus 35. Now, correlation's saying if it falls in a straight line or close to a straight line, then it's correlated. If the line has a positive slope, meaning as the hours of sleep increase, the scores also increase. That's what happened. They both increased. Then that's called a positive correlation, and the slope is positive. But let's look at example 2. I want to show you a different type of correlation here. Here we are recording sales of hot chocolate at a snack bar. And they're comparing it to the temperature because they believe that as it gets warmer, they're going to sell less and less hot chocolate. So we're comparing these. Here's the data for each day. On one day, the temperature was 20, and they sold 37 cups. Another day, 30, and they sold 33. The temperature when it was 40, they sold 30. When the temperature was 50, they sold 30. Temperature 60, they sold 24. 70 was 20. 80, they sold 12, which would be down here. 90, they only sold 10. And when it was 100 degrees out, they still sold 4. Some people really like their hot chocolate. So you can see this is definitely clustered in a path that seems to be a line. So let's find a good place to put our line of best fit. And so I try to play with it. It's good to have a clear ruler because then you can kind of see how many dots are above and below. I'm going to go with this one. So this line has 3 points above and 1, 2, 3 points below. This one's kind of on the line. And these were kind of estimates where I placed those dots. So it's just got to be a pretty close line. So let's pick 2 points to use to make our equation. This point right here is at 40, 30. And this point here is at 90, 10. So our slope was our change in y, it was at 30 and it went to 10, it went down 20. And our change in x, 40 to 90, it went up 50. So therefore our slope is negative 2/5. So it's going to be y equals negative 2/5 x plus whatever our y-intercept is. We're going to have to plug that into y equals mx plus b and figure that out. So let's pick a point. I'm going to use 40, 30. The y is 30. The slope we said is negative 2/5. X is 40. And we're going to work it out to find b. So this is going to become 8 if I cross cancel. So this is negative 16. So therefore I'll add 16 to both sides, and the y-intercept is 46. So I'm going to put 46 here. That is the equation of the line of best fit. And you can see that the slope is negative, and notice as temperature goes up, sales are going down. They're going in opposite directions, so this one is a negative correlation. All right, last example. On example 3, this is a scatter plot that's comparing a score on a test, a Spanish test, and height. Height has no effect on their score. And you can tell that that's true because the scatter plot shows no path. There's no pattern whatsoever. And so when there is no pattern, then that means that there's no correlation. So write no pattern, so no correlation. It's not positive, it's not negative, there's none. Okay, and those are your notes for today. If you have any questions, please let me know.